evidence that the planet Jupiter is the oldest planet in our solar system. This is beyond the asteroid belt. We have, as we know, Mercury, Venus, Earth, and Mars, the asteroid belt, and then we have Jupiter and Venus. Now, the international group of scientists has found that Jupiter is the oldest planet in our solar system by looking at tungsten and molybdenum isotopes on iron meteorites. The team made up of scientists from Lawrence Livermore National Laboratory and Institute for Planetology at the University of Munster in Germany found that meteorites are made up from two genetically distinct nebular reservoirs that coexisted but remained separate between 1 million and 3 to 4 million years after the solar system was formed. The most plausible mechanism for this efficient separation is the formation of Jupiter, opening a gap in the disk, the plane of gas and dust from stars, and preventing the exchange of material between the two reservoirs. This is what Thomas Kruger, leader of the author of the paper appearing in June 12 on the issue of Proceedings of the National Academy of Sciences, formerly at the University of Munster. Kruger is now at Lawrence Livermore National Laboratory, LLNL. He says Jupiter is the oldest planet of our solar system, and its solid core formed well before the solar nebular gas dissipated, consisting with the core accretion model for giant planet formation. Jupiter is the most massive planet of our solar system, and its presence has an immense effect on dynamics of solar accretion disk. Knowing the age of Jupiter is key for understanding how the solar system evolved towards its present-day architecture. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. Although models predict that Jupiter formed relatively early, until now its formation has never been dated. We do not have any samples from Jupiter, in contrast to other bodies like the Earth and Mars and the Moon and asteroids, Kruger said. He said, in our study we use isotope signatures of meteorites which are derived from asteroids to infer Jupiter's age. The team showed through isotopes analysis of meteorites that Jupiter's solid core formed within only about 1 million years after the start of the solar system history, making it the oldest planet. Through its rapid formation, Jupiter acted as an effective barrier against inward transport of material across the disk, potentially explaining why our solar system lacks any super-Earths, an extrasolar planet with a mass higher than Earth's. The team found that Jupiter's core grew to about 20 Earth masses within 1 million years, followed by a more prolonged growth to 50 Earth masses until at least 3 to 4 million years after the solar system formed. The earlier theories proposed that gas giant planets such as Jupiter and Saturn involved the growth of large solid cores of about 10 to 12 Earth masses, followed by the accumulation of gas onto these cores. So the conclusion was the gas giant cores must have formed before dissipation of the solar nebula, the gaseous circumstellar disk surrounding the young star, which likely occurred between 1 million to 10 million years after the solar system formed. In the work, the team confirmed the earlier theories, but were not able to date Jupiter much more precisely within 1 million years using the isotopic signature of meteorites. Although this rapid accretion of the cores has been modeled, it had not been possible to date their formation. Kruger said, our measurements show that the growth of Jupiter can be dated using the distinct genetic heritage and formation times of meteorites. Most meteorites derive from small bodies located in the main asteroid belt between Mars and Jupiter. Originally, these bodies probably formed at a much wider range of heliocentric distances, as suggested by the distinct chemical and isotopic compositions of meteorites and by dynamic models indicating that the gravitational influence of the gas giants led to scattering of small bodies into the asteroid belt. This is by Lawrence Livermore National Laboratory on phys.org. Please leave your comments and thank you for your support. Here we have, as we showed before, the rotation time lapse of Jupiter over 3 hours. And this is the actual red, the path completing the orbit of the Sun for every 12 orbits by Earth in blue. Jupiter is on the red line, as we can see. Now, Jupiter also has a number of very large moons. Here we have them, Galilean moons. The moons discovered by Galileo are Io, Europa, Ganymede, Callisto. Ganymede is probably the biggest moon in the solar system. They are the largest in the solar system, Io, Europa, Ganymede, Callisto. The orbits of the three of them, Io, Europa, Ganymede, form a pattern known as Laplace Resonance. There you go. The resonance occurs when orbiting bodies exert regular periodic gravitational influence on each other, usually because their orbital periods are related by a ratio of smaller integrals. So for every 4 orbits that Io makes around Jupiter, Europa makes exactly 2 orbits. Isn't that something? Okay, Io, Europa. And Ganymede, as we can see, that's bigger than Callisto. Europa makes 2 orbits, Ganymede makes exactly 1, and this resonance causes the gravitational effects of the 3 large moons to distort their orbits into elliptical shapes because each moon receives an extra tug from its neighbor at the same point in every orbit it takes. The tidal force from Jupiter, gravity affecting the stretching body along the line towards the center of mass of another body, and on the other hand works to circularize their orbits. Now, the eccentricity of the orbits causes regular flexing of the 3 moon shapes. So they also they flex their shapes, with Jupiter's gravity stretching them out as they approach it and allowing them to spring back to more spherical shapes as they swing away. Can you imagine what happens with the geology of these planets as that happens? This tidal flexing heats the moon's interiors by friction. This is seen most dramatically in the volcanic activity. Io, for example, the innermost 3rd largest of the 4 Galilean moons. This is Ganymede, Callisto, and Io. So you can imagine the volcanic activity of Io, which is subject to the strongest tidal forces, and to a lesser degree to the geological youth of Europa's surface. Okay, which indicates recent resurfacing of the moon's exterior. Okay, here we have the masses. Orbital period in days, about 2 days here. Europa 4 days, Ganymede 7 days, Callisto 16.5 days. As you can see, they distort because of the gravity of Jupiter. Jupiter has rings. Many of us don't know that, but it has rings. And Trojan asteroids in Jupiter's orbit as well. The Trojan asteroids are a lot of what comes to us as well. The Trojan is a small celestial body, mostly asteroids, that shares the orbit of the larger one, remaining in a stable orbit. And here we have Jupiter's rings. That's a lot of rings. And they even have names for them. Jupiter has faint planetary ring system composed of 3 main segments. the inner torus of particles known as the halo, relatively bright main ring, and the outer gossamer ring, and the rings appear to be made of dust rather than ice, as with Saturn's rings. The main ring is probably made of material ejected from satellites Adrastea and Metis. Material that would normally fall back to the moon is pulled into Jupiter because of its strong gravitational influence. The orbit of the material veers towards Jupiter, and new material is added by adding impacts. So I wonder if these things also bombard the moons of Jupiter. Anyway, this is from Wikipedia, and let's remember that the ancient Sumerians used to call Jupiter Nibiru. That's what we learned in a couple of days back. So the planet Jupiter was called by the ancient Sumerians Nibiru. Please leave your comments, and thank you for your support.